In this session, we are going to do two types of modal analysis. First one is called as a free modal analysis, where we will not apply any boundary condition, and second one is just free type of modal analysis where we will apply the boundary condition. Though we are going to perform the modal analysis on very simple component, you can extend this logic to any component or assembly for that matter. So let us begin. In order to open the mesh file, simply go for File, let us go for Open and go for LS-Dyna keyword file. Browse to the location where you have stored the file and simply open it. As you can see, here I have very simple file. I can go for the keyword arrangement in order to understand the content of the file. So here I have the 60 element, all of them are shell element, then keyword, then we have simple material, always better practice to check the properties of the material. Then let us go for nodes, and here I have one simple part, then we have the section, and then we have the title. As you can see, under the part it says there are two parts. As of now I am only able to see one part. That means there might be some empty parts. So simply double click on the part. From the tab you can see the bottom part is present over here, and here also bottom part is present. Now for the top part, let us go over here and let us say draw. As you can see, nothing is highlighting. So let me close this one, or let us expand this one. And here this particular part, if you want you can keep it, or if you want you can delete it as well. Since we are going to perform the free type of modal analysis, here we don't have to create any boundary condition. So only thing that we will have to do is to create the control cards. So simply let us go for all and let us start with the control. So first control card that we are going to use is the control termination, which is essential one. So let us go for control termination, and under the time let us put 1 second. Simply go for accept and go for done. Once the termination have been decided, now we will have to make sure that this analysis has to be carried out as the implicit analysis. So let us go for control and let us go for, let us say, control implicit. So we know in order to declare the analysis as an implicit analysis, we will have to perform implicit general. Double click on it. Under the IM flag, make sure that we are putting EQ1 for the implicit analysis. So simply put 1 over here, then go for accept and go for done. In addition to declaring the analysis as the implicit analysis, we will also have to tell how many number of modes we want to extract. So in order to do that, we can simply go for implicit eigenvalue. So under the implicit eigenvalue, the first keyword that we have is neij, that is number of eigenvalue. As of now, let us say we want to extract the 10 number of modes. So simply put 10 over here, go for accept and go for done. Now remaining card, those are not necessary, but if you want we can put it. Once the control card have been defined, let us go for output request. So we know in order to describe the output, we are going to use the database. So from the database, as of now, only thing that we required is the binary D3 plot to see the animation. And under the DT, since I have put 1 second as a time, let us put 0.1 over here, go for accept, go for done. Once the model have been built properly, you can go for model check just to check whether everything is appropriate or not. So let us go for keyword check and make sure there are no errors and warning. Let me again for the confirmation go for recheck. You can see there are no errors and warning. So simply go for done, and now let us save the file. Under the implicit, let me create one new folder. Let me copy the same name and let us go for save. In addition to this, since we want to perform the free type of modal analysis where we want to apply the boundary condition, let us create that file here itself. So simply in order to create the boundary condition, let us go for model, let us go for create entity, go for boundary and go for SPC. Make sure while creating the boundary condition, we are using the set as an option. Now we can go for bypath option and select the boundary edges. Once the node have been selected, make sure the degrees of freedom have been restricted in all the direction. Simply go for apply and go for done. Now again let us save the file. So I will go for save as, save keyword as. Here let me copy this particular name and let me say modal and simply save the file. Once both of the files have been created, let us submit our job for the run. Once the run gets completed, let us move on and post-process the results. First, we are going to post-process the result for the plate free type of modal analysis. Since we want to observe the number of modes, here instead of D3 plot, we are going to import D3 EIGV, that is eigenvalue. Simply double click on it and now you can play the animation. Over here, one of the important thing that we want to observe is the frequency. Keep your focus on the frequency, but just for our understanding, let us plot the displacement over here. So let us go for resultant displacement. Now, as we mentioned, we want to observe the frequency. You can imagine or you can think about this. Since this particular model does not have any boundary condition, that means it is free to go anywhere. In terms of CAE, we have the degrees of freedom. In case of structural analysis, we know that we have 6 degrees of freedom, out of which 3 are translation along the XYZ and 3 are rotational about XYZ. Now corresponding to those degrees of freedom, there is going to be frequency which will be null since we don't have any boundary condition. Now what essentially boundary condition does is that it will restrict the motion in that direction. Since we don't have any boundary condition, that means this object can move along that direction very easily. Since there is no restriction, automatically the frequency is going to be 0 only. So you can observe over here it is saying mode number 1. Let me put that over here. So mode number 1 and corresponding frequency is minus 0.002. So you can consider this as equal to 0 only. The same frequency you can observe over here as well. Now let us go for mode number 2. Again, the first 6 frequencies in case of free type of modal analysis are going to be equal to 0 only. So again for the mode 2 we are getting 0 frequency, mode 3 again 0, mode 4 0, 5 and 6. So I hope you got the idea about these first 6 degrees of freedom. These first 6 modes are commonly known as rigid body modes. Once the 6 degrees of freedom have been completed, there is definitely going to be resistance from the structure. So instead of frequency to be 0, you will get some frequency. So for the mode 7, you can observe the frequency to be equal to 2075 Hz. You can move on and check the frequency for the rest of the modes. You can also check how the mode shape is looking like. So this displacement formation is nothing but mode shape. This was the case for the free type of modal analysis. But in case of free type of modal analysis, we have applied the boundary condition, so there is going to be resistance from the first degrees of freedom itself. So let us try to open that particular model. You can imagine, since we have the boundary condition, from the beginning itself we are going to get the considerable frequency. As you can see, for the mode number 1 itself, we are getting the frequency equal to 7140. For the mode 2, again you will get particular frequency. Not only that, here the interesting thing. For the mode number 1, we are getting the frequency equal to 7000. And for the free type of modal analysis, the first fundamental frequency was around 2000. So obviously, whenever we are going to restrict our structure through the boundary condition, the frequency is going to get increased. In order to see the mode shape in animation, you can also click on the play button to observe the motion. So I hope with this simple example, you got the idea about performing the modal analysis in LS-Dyna. We will meet in the next session. Till then, take care. Goodbye.